Sweet. We are on logarithms, page 10. We're doing the example at the top of the page. We have log base 3, 7 minus 2x equals 4. You'll notice my x is in the middle here. And in order to solve for that, I'm going to put this in exponential form. So we're going to do a lean to. Let's lean to the left, we'll get 3. Lean to the right, get 4. Equals the middle, get it right. 3 to the 4th would be like 3 squared times 3 squared, which would be 9 times 9, which would be 81. Equals 7 minus 2x. I'll subtract 7 from both sides. What is that, 74?
Yeah.
Equals negative 2x. Divide both sides by negative 2. I get x equals negative 37. Now, if you look back here, it's minus 2 times 37, so this is going to end up being positive, so this is an okay answer. All right?
Yep. Oh.
So this is not a throw out, because it does check.
Mm-hmm.
So don't assume just because you solve something and get x is negative that it's not going to work.
Okay.
It wouldn't work if you have something that says log x.
Mm-hmm.
Or log something where it's going to end up being x. It's
Yeah.
not just because it's negative. It's when you plug it back in, is it going to work or not?
Because it's multiplied by another negative in this
Since it
case,
doesn't,
which-
exactly.
All right.
So in this case, it's going to end up being okay. Alrighty?
Okay.
Okie dokie. So let's look. And this next thing we're doing is really clever. I like clever. So we're looking at log base b of a equals x. And we're going to put this in, what do I want to say, exponential? So let's b, lean to the left, lean to the right, equals the middle, get it right. All right, so what I'm going to teach you guys is we're going to take, we're just going to do some fancy work here to show you something, okay? We're going to take the natural log of both sides. I'm going to do the natural log of b to the x equals the natural log of a. So far, so good?
Mm-hmm.
We are going to use our come on down property, the Price is Right property.
Mm-hmm.
Come on down. So this actually equals x times the natural log of b equals the natural log of a. And I am going to solve for x. So that means I'm going to divide both sides by the ln of b. And that gives me x equals the ln of a over the ln of b. Now why is this important? Well, in our calculator, we can only solve for things that are log base 10 and log base n. This allows us to solve for any base in the world. Okay, any base at all we can use. So, but you see how we took the natural log of both sides here? We could have just done log of this side, log of that side, and it would have done the same thing.
Uh-huh.
So at this point, I could have said b to the x equals a. I could have done log b to the x equals log of a. X log b equals log a. Solving for x, I get log of a over log of b. Essentially, the only difference in these two is that this is a natural log, this is a log 10. Okay? It doesn't matter which one, if you want to take log both sides, natural log both sides. People tend to do natural log both sides just because you have fewer things to write.
Okay.
But it does the same thing. The cool thing is, your base, the base that you have here, is going to be your denominator.
Mm-hmm.
And the number in the middle is going to be what your numerator was, and you can solve for this here. So you can find bases of different things. So let's just do an example of it. Okay, at the bottom. And this is basically, this is a rule that you're going to want to kind of commit to memory. Okay? And so I'm just going to write it out here. It was x is equal to the ln of a over the ln of b. And it looked like log base b of a equals x. Okay. So x is equal to this puppy, and then they want us to find log base 3 of 12. Well, what is that? Well, it's going to be the ln of 12 over the ln of 3, and we can type those in our handy dandy calculator. So ln 12 divided by, whoops, make sure you put your parentheses in the right place. I got 2.26185, yada yada yada.
Mm-hmm.
So far so good? So let's look at our next one, log base 7 of 0.4 is approximately what? Well, it's going to be the ln of what? 0.4 over ln of 7. Use your calculator. ln 0.4 divided by ln of 7. It's negative 0.47088 dot dot dot. And our last one here, log of base 0.2 of 1.5 is approximately what? Well, it's going to be the ln of 1.5 over the ln of 0.2. So use your calculator. ln of negative 0.25 19296 yada 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 yada. Okay. Now, if you had done the log and the log instead of ln, you would still come out with the same numbers at the end. It doesn't matter which you do.
But they just do ln because it's...
Well, I think typically when we write it, ln is shorter than log, and that's why we tend to go that way.
Okay.
But it's essentially the same thing. Okay? So we can kill that recording.